So Thomas didn't come. Thomas came last time. He was really fun.
Let me just make sure that this starts. That I'm watching myself.
Yeah.
Yeah, go to Inception.
Very, very meta. Okay, cool. Let me just make sure this starts. Excellent.
Cool.
Let me, play and then watching myself. Get out of there. Okay. All right. So I'm still screen sharing, still broadcasting, and everything's ready to go. Cool. We only have 2 people here, so I don't know if we should wait, but it's 5 after. I say if other people want to come online in a bit or whatever. Greg said he was going to be online. There were a couple of the other attendees that said they were going to be online only. So
maybe while you're waiting a little bit, did you say you were going to try a Linux for the next session? Have you made up your mind?
Let's talk about that, actually. Ike, did you have some ideas about what we want to do next time?
Well, we've done Linux already, and I'm happy to do it again. I did think that it's well past time to do Docker and Kubernetes. I'm also fine doing another analytic track like Python for analytics. I'm also fine doing Spark. So right now, Apache Spark is hugely popular, and a particular iteration of it called Databricks is really popular. We've never done kind of a back-end data engineering thing like Hadoop before.
That's true. Although we did Hadoop for the SQL group at one time, if you remember.
Yeah, that's true. We did.
So let's put those up. So Docker Kubernetes, that's definitely one that we've talked about doing in the past.
Yep.
Mentioned Apache Spark. Databricks?
Yeah.
And then also you mentioned
Python for data analytics.
Okay.
And then Carl wants to talk about Linux again.
No, it just what you had. I saw that on the site.
Yeah, we just hadn't updated it yet, but
yeah.
But we're happy to do it again.
I think if we do Docker Kubernetes, that's going to be fairly Linux based anyway. I mean, a lot of the although there are 2 types of Docker, the Linux type and the Windows type, it'll be.
Nobody cares about the Windows type. I've never met a single person who ever cared about the Windows Docker.
I have a couple, but I agree the Linux flavor is far more common and far more used. Let's put it that way.
So Thomas just RSVP'd yes just now.
Probably online, if I had to guess.
Yeah. Oh, maybe you're right. Darn it, Thomas.
We should put the disclaimer to say only RSVP yes if you're actually going to be in the live site. We should put that in the actual text at the top.
Well, I think they like to RSVP because they get the calendar invite automatically and they get reminders automatically. So I'm not sure we should say that so that, I mean, they like to use Meetup for the reminders and things.
Yeah. But it just makes it hard to figure out ordering.
It's like we need 3 options. Yes in person, yes online, or no.
They don't let you customize that.
No. All right, it was 10 after. I say let's go ahead and get started. And then.
Well, wait, we were going to choose a topic. You want to do that afterwards?
Yeah, I want to do that afterwards. I just want to talk a little bit about some of the choices. We'll mull it over while we're talking about R and its sort of background processing.
All right, sounds good.
All right. So the first chapter that we were supposed to read tonight was chapter 18, which is about modeling. And that was one, if you recall, last time that we postponed because it was so complex and we had like 15 minutes left. I will say that I both liked and loathed this chapter. So the parts of it, I would have liked it better if he had said, R has a really simple and powerful way of doing modeling, especially linear modeling. Mm-hmm. And we're not going to talk about that yet because I want to talk about how to do it, you know, the old-fashioned way.
Yeah.
And then, you know, and then we'll go into that later on. But he didn't say any of that. He was just like, okay, so let's start modeling, you know, and it was like, okay, all of this, you know, that picture, here, I have it up here.
Everyone's heard of a linear regression, right?
Yeah.
So you're like, how come he's not talking about that?
Yeah.
Right? Yeah. I actually, I thought that part of it was really cool. Like, here's a way to explain modeling without any statistics.
Yeah.
Whatsoever. Without any linear algebra, without any statistics, any math.
Yeah.
Like, look, you could do a quick search and you could just randomly see what.
Yeah. No, I liked the way that he approached it. I just wish he had said, there is an easy way.
Yeah.
You don't have to do all this stuff. I'm just going to do all this stuff to kind of explain the process for producing a model, right? Right. It just bothered me that he didn't say anything up front. So,
you know, Scott, I think that's like a microcosm for the whole book.
Yes, that's
like
so true.
Starting with ggplot, like if he had just said, like, you know, you're probably expecting me to introduce variables and data types and stuff. We'll get to that around chapter 10. But like, you know, picture yourself as a, you know, brand new data guy. Yeah. Let's start visualizing the data.
Yeah, exactly.
Bear with me. You don't understand the syntax, just bear with me. If he had just had that
little blurb,
it
would have made the book a lot clearer.
I can hang in there. I see where you're going now.
Yeah. So I was like, God, why? I'm sitting here reading and going, you know, this stuff, it's so tedious. Do we have to do this every time? No. And then like at the very end of the first part, he's like, oh yeah, and there's a function LM that'll do all this for you.
And it will do much more.
Okay.
It's fantastic fun.
Yes. And so, let's see, did I do any of these exercises? I didn't do very many of the exercises. I think I did do these though. So this, I was sort of following along his long walk through. Yeah, and there was the final LM function, right? Which all of this stuff, you know, was basically the equivalent of that one little line. Yeah, the exercises he's asking about, is it sensitive to unusual values because of the distance uses a square. And he says, try and use the simulated data below and see what happens. And this data has a lot more outliers than the original set that we were given. Right. And that affects the slope a lot more. And you can see it actually in the, what is this thing called again? The
outlier.
The shaded area, the
confidence level.
Confidence interval.
Yeah, confidence interval. Exactly. Thank you. So the confidence interval, you know, starts skewing, you know, at the ends there where the outliers are present. And then doing a little research, it's because we're using a different distribution, slightly different than the normal distribution, a student distribution. Anyway, so one way to make linear models more robust is to use a different distance measure. And so he basically says, you know, use this mean absolute difference and go ahead and plot this data. So you do that, and it does produce a slightly different slope from the one above. So, okay, it did change things, so that was good. And then one challenge with performing numerical optimization is that it's only guaranteed to find a local optimum.
I didn't understand that. That's the one statement I didn't understand. I even tried to Google that a little bit.
Yeah, so I only get it from, way back in the recesses of my mind. I used to be a math major. I haven't used it at all since I graduated, and that was a long time ago. So, but I remember doing like a numerical methods class or something like that, and especially if you're in more in-dimensional space or whatever, you'll find an optimum here, but it turns out if you were actually take a global view, you're standing on the top of a hill and there's a mountain right next to you, right? And you found an optimum on the hill, but if you had just started at a different place, you would have found the top of the Mount Everest, right? But here you are, you're thinking you've found the answer, and
I see. Yeah,
it's just a tiny
that's a
little
good
rock.
explanation.
Yeah.
That's a good explanation.
And that's kind of what he's asking about here, because different permutations of these numbers would all basically add to the same thing. Addition is commutative, right? So it doesn't matter if you take 1, 2, and 3, or 3, 2, and 1. They all sort of get the same thing, and basically, so you have just large number of local optima in this function, right? And that's what makes it tricky. Welcome, everyone. There's pizza, by the way, over there on the left, and some soda, and some even I think a dessert type pizza. All right, so that stuff was fairly straightforward, I think. Any questions on that stuff?
Was he doing polynomial? I'm sorry, I cannot see well. Did he show polynomial regression? I didn't read that far.
I think that's
Just
later in the chapter.
Yeah, it's later in the chapter. Later in the chapter. Absolutely. Yeah, I forgot I was not zoomed in. Okay, so then he started talking about visualizing models, which, being a visual person myself, I loved, and he started talking about add predictions that function from modeler, how do you say that? And which will basically add a new column to the data frame with predicted value, which, straightforward, easy. And then the next part I really liked, because I had forgotten all about residuals. I had no recollection of this in my math brain, which it was very dusty, but even dusting it off, I had no recollection of this. Maybe it was in statistics and I just ignored it or slept through it. I don't know. But he started talking about after you basically, it's like showing the deviations between the model and your actual data. And I like how he plotted it out, and it was basically like a, let's see if I can find it up here. Okay, predictions. Yeah. So he plotted it out as a frequency, and then he plotted it out just as points. And I like he said, and it looks very random and even distributed, evenly distributed. So it's good. That's good when you see residuals like that. And later, that stuff came up again when we were in chapter 19, when we started subtracting visuals and seeing things that were actual patterns. So I don't think I did these, did I? No, I did not. Yeah. So we can go through them if you want, or skip them. It's up to you. I don't care. Thoughts? Ike, did you do them?
I'm fine either way. I'm going with the mood of the crowd. There's nobody online but me, and now you've got like a small herd of people there.
Yeah.
Well, I would like to mention, if you do plot your model, which is usual model, then you will see 4 graphs for residuals, and it could be useful.
You'll see 4 graphs for the residuals?
Yes.
Full, I think she
Do you
said.
have any
Oh,
more?
full. Okay, full graphs. Right. If you plot all of the data, you're saying.
No. If you use plot function in R and you
Ah,
write plot, type plot your model
yeah.
in parentheses, then you will see this 4 graphs.
Okay. Let's take a look.
So you have any model?
Yeah, I
Which
think
is
we
done
do,
with
right?
program
We had one up
function.
here somewhere. Hold on. Maybe not.
It has to be one that you ran LM, not one
Yes.
that you did by hand.
Yeah. Okay, so I have sim1 mod, right?
Uh-huh.
Okay. And so then if I boom, and I say plot
Yes. If you say plot,
sim1 mod, anything else?
that's it. There's this in parentheses.
I need to like rerun. Hold on.
Oh, sorry.
Yeah, you started it and you didn't get everything in memory.
Yeah.
Yes.
Okay, there.
Yeah, yes, there
Yeah.
should be 4 plots actually. So here the residuals.
Residuals versus fitted.
Uh-huh.
Normal QQ. I don't even know what that
Yeah,
means.
that's some characteristics.
Okay. Scale location. Interesting. And residuals versus leverage. I don't know what those things mean, but I assume they have some statistical
But
relevance.
if you want to know more about residuals, these graphs are useful.
Yeah. That's true. That is true. Yeah, that basically that top plot is very similar to the one that he did, by hand or whatever.
Yes. Also, usually they, in a grid for 2 by 2. Oh well. Okay.
Well, yeah, that could be just because I'm zoomed in here in the browser. Yeah. So. Yeah.
So the other comment that I would make that in the book doesn't really comment on is, like, at this point, I believe he's talked about lists and attributes, and so there's a certain amount of what's cool about R where the statistics community has sort of agreed on conventions on what you're going to name these various things that get packed into the output of a model, right? So if you actually do like stir on that model or whatever, then you'll see explicitly there's like 12 things in there or whatever. It's not just, what are the coefficients or whatever. And so
wait, so you're saying the
data frame? You're talking about the columns and
you're talking about
frames?
yeah, structure
of
your sim1 mod.
sim1 mod.
You can see there's coefficients, residuals, there's all these other things in here, right? Which plot or other stats packages or tools know how to use. And you don't really have to even know they're there. But if this linear model thing and generalized linear model and other things all use the same naming convention, then these other tools can just go in there and they can plot things and do stuff because they just know where to. But these things are sort of just hidden in this, in this output of the.
It reminds me of, Scott, it reminds me of MVC data binding, or in some regard link mapping up, properties with, anonymous types. Like there's some black magic in these frameworks that we don't understand. That
R is not strongly typed, so you can just kind of glom on as many things as you want.
Yeah, but it is a list, So if you want to get your coefficients, for example, the first thing, you can type your model. Use.
I could basically
$sign. And
$sign coefficients.
Yeah, and I think he does that somewhere where he says dollar coefficients. But the cool thing isn't just that it has all this stuff. The cool thing is that if you had used some other tool, it might have had the exact same attributes, same named attributes that then plot and other tools know what the heck to do with these.
Yeah, in particular, plot knows many things about many other structures in R. You can plot this model. You can plot a tree model. It will show you a diagram for tree. I don't know if he does it or not. Also, plot doesn't do good picture for this for a tree model.
Yeah.
Well,
but so to me that's one of the fundamental things about like, well, why do you like, if you ask someone if they like R or maybe they like Python, but if they actually like R, like part of it is that there's this stuff here that you can leverage as opposed to having to like manually take all those little data elements and feed them into some function as, you know,
an argument list or something.
Yeah, right.
Mm-hmm.
Well, Python people said that Python is more efficient in using resources because you don't have all this stuff in it hidden.
Yeah.
There's always a memory, compute time trade-off. Right? Okay. Cool. All right. So.
Yeah, we had that discussion 2 months ago where we said, you know, the problem with hacking is that you can actually get stuff done really quickly if you're willing to hack, you know. And yeah, R promotes that behavior, and so you have a strong feeling of moving forward. That's kind of addictive.
Yeah. Okay, so the next part was formulas and model families. And he started talking about, you know, if you have categorical variables or continuous and categorical, and then finally 2 continuous variables and how they can interact and how you can determine the models of their interactions, I guess. Okay.
A question. Anybody look up the lawless function? Because the only thing I could find about it is that it uses Spline interpolations.
Oh, that one is on. Yeah,
which has a smooth curve.
So I found this.
What page is she talking about?
About the exercise?
Yeah, the exercise. If you have the hard copy, it's like 358.
I'm just asking if anybody knows. He doesn't talk about it in the book too, so I was always wondering how it works because the only information I could find about it is that it uses Spline interpolations, and that's it. And it adds them somehow.
Yeah.
So anybody knows?
No. I've heard of it before, but I don't know how it works under the hood.
Process of model fitting.
I think I did Google it a little bit, and I got the impression that rather than just a straight linear interpolation, it sort of had the capability to break it up into segments to more approximate the curve somehow.
Well, I look for a while and I found that it uses Spline interpolation, which means that it uses pieces of polynomials on different parts of the curve.
So it's different
but that's it. I could not find anything else.
I didn't find much more than that.
Well, and there's a parameter that says how narrow
smooth it should be.
Well, how smooth, but really it's how much space between splines, right?
That's true.
Right.
So I'm wondering how much space is between these pieces. I wonder how exactly.
I don't know that. I did play with changing that, and you definitely see that the bigger the number, the.
Okay, so you can change this. This is an option. Okay.
It's a parameter.
It's a parameter. And I actually did exercise 1, and if you use that lowest function, whatever, then you I actually got the same curve as the geom smooth.
Yes.
So that was like pleasing.
Yeah.
Well,
oh, look at that.
It's one of the default.
Yeah, it's the default. It says.
Right.
Sometimes it uses it if I don't remember if there are too many points or too little points, but at some point it uses this.
Yeah, he does say that the
Mhm.
default for GM Smooth is that Loess. I don't know how you say that.
I don't know.
Loess function. Okay.
So GM Smooth is based upon that.
Yeah.
Yeah. So if you took this plot that's on the screen
Mhm.
right now, Scott, and you set the I forget the name of the parameter, but to a really tiny value,
Mhm.
right?
Mhm.
Then instead of smoothing, it would basically just kind of, be
Oh,
following the
oh,
lines,
thank you.
right?
I think I'll try this.
Yeah.
It will be interesting.
I like this one too, where he plots the difference in the residuals between the Loess function and the standard linear thing, just to show they definitely differ.
Yeah,
But
ever
not
so
much,
slightly
yeah.
better.
Yeah.
I looked at that pretty
Yeah.
close. I was trying to go, boy, that is not a whole lot closer when you
Yeah.
take the average error
Yeah.
between the two different methods.
It's different.
It is different.
And I think it would probably work better with some data than others, right? It depends on your data. This is obviously this Sim1 or even the Sim mod or whatever, the Sim1 and Sim, I don't remember what they were, but the two different data sets that he's been playing with, they're very linear, right? So a nonlinear smooth based function, it's only going to get you so much more, right? But if you had data that was a little bit more, flowy and not so linear, then this would obviously be the right tool for the job.
Well, I mean, I think Loess will always give you a smaller error than the linear. Worst case, it'll give you identical if it just outputs the same thing, right?
I don't know about that.
But a smaller error on your training data doesn't necessarily mean a better model on your real world. You might just be overfitting noise in your training data.
Yeah.
Well,
that's true.
polynomial, yes. If polynomial is high enough degree, you can fit anything.
Yeah,
Which
but
is
again,
but
fitting
if
it
you-
exactly to the training
You
data
don't need it quite
isn't,
often. Yeah.
isn't necessarily the right thing to do.
Mhm.
Okay. So I guess after that he starts talking about transformations, and he uses square roots and squared transformations here. And I think this comes up again later on when we start doing the logarithmic transformations related to caret, I think, in diamond exercises. And then he does show at the end of this, let me go over here. Where are we? Transformations, okay. And then he does, when we try and approximate the nonlinear function, and then he tries to fit 5 models to this data. And this is what you were talking about. I think as you increase the polynomials, it gets closer and closer to the actual function. And he ends it with a little caveat. Notice that because it is a function, it may extend beyond the range of your data, and you actually don't have any data off the end of it here. So who knows what that's doing and if it's going to model it or not, and probably not. So, make sure you, take care when that happens, I guess.
Yeah. Polynomials always go to infinity or negative infinity.
Yeah.
They never are asymptotic or go to 0.
Yeah.
So if that's not real world behavior, then beware.
Yeah, it doesn't look like it would be here.
But you can use, sine function here too.
Yeah, a trigonomic function would work here as well, it looks like. But
yes, and you can use it in Visual function.
Oh,
You can use LM. You can use instead of just x, you can use sine x.
Yeah.
But you need, to guess the period, right? Well,
Mhm.
not x, but with multiplied by some coefficient and plus some, again some coefficient as a phase and such and such.
Yeah.
Well, anyway, it could be done theoretically.
Yes.
And I've seen it.
It's based off of it. I mean, like
Yeah.
the data set itself is based off the sine
Mhm.
function, so you could figure out,
Yeah.
Those values, and I'm sure that would very closely match the data because that's the function that's ultimately used to produce it. Okay, so is there anything in here that we want to talk about? So categorical variables into 0, 1 variables. You mentioned that, I think, when he was talking about gender in the beginning of the chapter.
Did he mention dummies? There is a dummies package in R, right? And it creates from any categorical variable, it creates variables which have 1 and 0.
Oh.
Yeah. And yeah, you can do it by hand too, if you want.
I don't think he mentioned it because like LM, if you just give it a
if you give it a factor, it will
automatically
okay.
behind the scenes for you.
Mm-hmm.
So if your factor has 5 levels, it'll create 4.
Yes, I know. And it will drop the one which is the worst for prediction using the Akaike criteria. Yes, that's true.
Yeah, I don't think he mentioned that function if you wanted to do it yourself, which is weird because that's normally his MO. He would be all about the first, let's do it. I'm not going to tell you that this thing exists. First, let me do it myself, and then, but for that.
And then after you realize this is a pain in the neck, oh, by the way, it just gets handled automatically by this other function.
I was curious why it picked male instead of female as the value to be 1, and show up in there. And the reason turns out I started plugging in different names in alphabetical. That's all it is. That was all it was.
Mm-hmm.
Okay. So if it's Boolean, then it really doesn't matter which it picks, right?
Yeah, it can pick one or the other one of them. Yeah, it just happens to pick the highest in the alphabet. M came after F, right?
So the last part of the chapter is other model families, which, having no real statistics background myself, I was just like, okay. But there's your trees that you were mentioning earlier. There is a R-part tree type model. But I don't know enough about the additive models and the penalized linear models and the robust linear models and the trees.
Penalized linear models is what? Is it elastic? Elastic, yeah?
I don't know enough.
I don't know, but we can go. Hold on. Can we do this? Can you take a random thing that doesn't have?
No, I don't think so. But you can go to CRAN and look it up.
Okay. I can't do that.
I think it's because you haven't installed it, so it's not available in help.
Right,
once you install it, then
then I can do it. Okay. So if I go, you're saying crayon?
To CRAN.
Oh, CRAN. Go CRAN.
Comprehensive.
Yeah. Sorry, I know that thing. Let me just do a search there.
This is not CRAN.
Oh, this is not CRAN.
I think that's Google click.
That's weird.
You know what I'm talking about?
Yeah,
those clickbait sites.
All right, R CRAN. There, that's the one. CRANRproject.org.
Yeah.
Okay, and we're
so there's a link for packages.
Sources, binaries,
Yeah, you can.
packages.
Packages. Table of
And-
available packages sorted by name.
And then we
Here
could
they
go
are.
down to G.
You can search in a page.
Yeah. G. Hook me up. GLMNET. Why didn't it?
Keep going if you want the other one.
There. Lasso and elastic net regular. Yeah. So
Oh,
both.
okay. Elastic, yes. Lasso, yes. But elastic net usually, contains a rich regression too, right?
I don't know. I don't know this stuff that well. I'm not a statistician.
Okay. And, I'm wondering, like, if you're not going to actually talk about them, it's weird to, like, I don't know, it felt weird, like, oh, yeah, and there's these other things too. Okay, moving on.
And they
No, I think what happened here is he teaches out of this book, and this is basically him feeling out the class to see if they want to talk about it, and if they do, he'll talk about it, and if they don't, they don't. Yeah. That's the impression I get when he does a lot of this stuff, is he just wants to remind himself that the topic is there to be introduced.
All right.
Well, he didn't say that logistic regression is done by GLM.
Yeah,
you should mention the correct family distribution family there.
Yeah, I did. Generalized linear models, stats, GLM. Right here.
I thought he mentioned logistic regression somewhere.
But I don't see
actually
here
a little while, a
logistic
few weeks ago that I
here.
looked at this. So I thought it was in the main chapter somewhere he mentioned.
Okay. No, I just mean that he should say that GML in particular does logistic regression.
Well, the only place I would see it is here.
Maybe
I don't see it in the index.
Yeah. No, it's in my early edition, and this is later edition. So it's in the other model families at the end of that chapter. Right. In mine, that's like 18, and here it's chapter 23. But regardless, the other model families section is where he has the other families that you might consider using. I don't know. See, he doesn't say like when you would consider using them, or like what would force you to use one versus the other, or like I was sort of expecting a little bit more like explanation, but as Ike is saying, maybe it's just he's just sort of reminding himself that other stuff is there in case there are questions, or he has to cover it at the end.
Kind of like you, Scott. I really had to go back into relearn a lot of the math that I'd forgotten.
Yeah.
One thing I appreciate about this book is it made me realize to really be a data scientist, you better be a pretty good mathematician, in my opinion. Yeah, I think there's people out there doing this sort of thing, but I kind of got the feeling the stronger a mathematician you are, you're much, much better.
Yeah,
you got to understand your stats for sure.
Well, yeah, that and some other stuff too, depending on which area. It seemed to me like linear algebra wouldn't hurt, in some other areas like that, the stats for sure. Yeah.
Yep. All right. So that was the end of 18, and then we move over into 19, which is on model building. And I loved the beginning of this chapter. The why are low quality diamonds more expensive? Mm-hmm. Like, I love the contrast between these box plots at the beginning and after we got through, taking out the carrots, then the world made sense again. Like that was a great exercise.
Yeah.
I felt, and for once, I felt like he covered it like with the right amount of prep and sort of leading. I told the story, versus like here's some information that you don't care about, or some of the other things that he's kind of guilty of. So yeah, I like the fact that you could see that it's exponential here, and he uses logs to add those two, those two logs to add the additional columns in. And when you plot that, it's very linear, which was excellent. He talks about what is that called? Strifing or something like that, right? And he talks about these bright vertical lines, right? This is another situation where it's that human.
Yeah, the frequency is higher at certain round numbers.
Yeah.
Because that's the people look for a half carat diamond or whatever. They're not looking for a 0.418.
Yeah.
Carat diamond.
If only I knew this 2 years ago.
Yep.
I hesitate to think of how many years ago that was for me. All right, so, and then, he produces the model. He looks at the residuals, and I like the fact that the residuals also look like a nice circular random cloud, and then after incorporating those, then the plots make sense. I thought that was great. And then he goes to say, all right, can we improve it? And I also liked how he says, okay, kinda, but not really. But he printed it in the book, I thought that was kind of nice too. He goes down the path of what can we do to improve it, blah, 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 blah. And he's like, it's probably nothing that we can do to improve it. It's probably fine as it is. But he actually printed all that stuff rather than just concluding the chapter. I thought that was also nice. So he talked about the bright vertical stripes. So the relationship between price and carat, basically as you go up 1% in price, you go up 1% in, as you go up 1% in carat, you go up 1% in price. Extract the diamonds. Yeah, so this number 3, I don't think I did this one, but I'll go over here. Anybody do this one? The extract the diamonds that have very high and very low residuals. Is there anything unusual about these diamonds?
I guess it's his answer before, which is probably, I don't see anything unusual here. Maybe.
Let's see if let's see, model families, model building. Let's see what he says. Yeah, this doesn't seem terrible to me. Okay, and then he goes through the daily flights data, which is, again, we've looked at this data so many times by now. And I also kind of like this because I liked how terrible the visualizations were in the beginning. And it wasn't until he got to yet another model, that things started, really, I think, looking like they should. Mm-hmm. So he starts about the seasonal Saturday effect, and there's that data, and he tries to plot all the seasons independently. That still looks like crap. And then finally, somewhere he goes yet another. Okay, he does computed variables first, and then he does time of year, an alternative approach. And that, to me, was like, okay, I can totally see what's going on in that, although that color is horrible, in that, plot. There, you can see Sundays below the weekdays, that all the weekdays are very similar. And then Saturday, very low in terms of January and whatever it is around Thanksgiving.
November, yeah.
But
And right before Christmas, I guess, a lot more.
yeah, zooming
Yeah.
around Christmas and the beginning of January time, yeah, or the end of the year time, yeah.
That's fascinating.
Yeah.
The one thing that I don't remember him doing that I would like to have seen is for him to build this spline using 70% of the data and then show how well it predicted the data that he reserved.
Yeah, he doesn't do any sort of like what is it called, area under the curve, or dividing it into a training set and a
Right.
testing
Training,
set,
yeah.
and then
Yeah, and even if this was just a very tiny example, just to show the process of, look, at first I pulled 70% of the data randomly, I built these curves, and then let's see how well they predict the other 30% that I didn't.
By the way, I've never heard expression query set. I usually hear test set, validation set. This is the first time when I saw expression query set, which he used.
query set.
Larry, does he say that?
He said query set
Maybe it's
at the
because he's a
very
Kiwi.
beginning in the introduction.
You know he's from New Zealand, right? So
Ah,
so maybe they just
query set.
they say that there. I don't know.
Actually,
Yeah,
in SAS, you use all the three terms. If you're using SAS, they use all the three terms: test, validation, and training. But I'm not very sure
It
in
is
R.
called query.
No,
But
in SAS,
query,
no.
yeah.
Not query.
Not query.
If you go
But-
to introduction, he talks about it.
Okay, you're talking about the introduction of this chapter?
Yes, introduction to this chapter.
Into
Introduction model and introduction 22.
that part. I see what you're talking about.
Yes. And a bit below,
What happened?
more
Sorry.
below. Well,
Yeah,
he
query
calls it
set.
a query set, and I've never heard such expression. People usually say that we have a test set, that we have validation set. And usually validation set is the very last. Also, I'm not sure if this terminology is set up. I know different people say different things. And besides, we have cross validation, which is not at the end, so it could be.
Well, I have
confusing.
heard training and then multiple test sets, like a test and a validation set. I've heard that, like both a test and a validation set.
Mhm.
And I think maybe that's what he's, the
I think-
query set, he's like,
He decided to introduce another expression.
yeah.
Maybe. Okay.
What they taught us to do in our stats course is typically you do kind of a tenfold cross validation. So you do 90% training, 10% test, and then you do a different 90% and a different 10% test. Do that 10 times, so you've tested everything and you've trained on everything 10 times.
Yes, and then you pick up the best parameters using this.
And yeah, then the average, the results.
But I think you're right, Scott. I think he's saying you might be doing expiration on 60%. When you go to build your model, you can throw in an extra 20% to see if that changes the performance at all, so that you're not potentially like over fixating on just some random phenomenon in your data.
Yeah,
And
I think
that
of this as
20%.
like a dev set. This is what he's talking
Yeah.
about, right? It's like, just making sure, like a comparison set, like a unit test, sort of situation, and then the actual tests, for real, the validation test set. Yeah. So yeah, it's like a unit test set.
He doesn't want to cross
I
contaminate.
understand. It
Yeah.
is just, I've never seen such
Yeah.
expression before.
Query
Yeah.
set.
Yeah,
Yeah,
I've
no,
never seen that.
I haven't seen it yet.
Yeah, that was good. Okay, where were we? So I think we got through. Yeah. And then again, at the very end here, he's like, if you want to follow up, here's some books. I don't really want to, doesn't really go into. Yeah.
Yeah, so
You know,
Scott,
the second one is very good if you don't remember statistics well, because it explains a lot. The first one requires very good, knowledge of statistics with which you work, because these people use a lot of definitions and formulas and notation, statistical notation, which even I don't remember because I did it years ago.
Yeah.
But the second one is, and I didn't try the second one I liked a lot because they explain a lot. They don't assume that the readers are good at statistics and that they remember it well.
And then he says this last one, this is like typical him, right? Applied predictive modeling is a companion to the carrot package.
Carrot package is fantastic, but it is complicated. But it is absolutely fantastic. It's amazing, but wow.
Anyway, so that was.
But yes,
it
deserves its own book. That's true.
Yeah. Also available for free.
Yes. So if you want to learn more about all those other packages, go and read these books, and then you'll be an expert.
I have 2 of them, maybe even with me.
I have the bottom one.
Oh, you have the bottom one. Can you
The
share?
carrot one. So then he goes into this confused the living crap out of me. I'm sorry. It was just really, I don't know if it was the language or what it was. Maybe I just wasn't in the right mindset, but this was for me the most confusing chapter.
It was hard for me as well, but I kind of got the overall impression that it was a way of embedding your formulas as part of the data set. So the formulas it was self-contained in a sense. So as some of the columns would actually contain, you could have multiple formulas for fitting along with your data. That's what I sort of got out of part. It went deeper than that, but
yeah. Well, you got more than I did out of it because.
Oh, I had this book too.
I think Scotty's really just trying to say that you can put the equivalent of a data frame into the individual cell of a parent data frame.
Yeah.
Oh, the nesting part.
Nesting part,
yes,
right?
Yeah.
Okay.
Yes.
And that, so you can imagine that if you had data that was sort of whatever, then like if we normally think about, he had like group by country.
Yeah, group,
right?
Yeah.
Right.
So it's like a group by without, like in SQL.
You would have 2 separate tables with a join.
Yeah.
Okay.
Yeah, I jumped ahead.
And if you unnest, you denormalize and flatten it, then what you'll get is that cross product with repeated values.
Right.
Right. But if you don't want all those repeated values on the parent table, you can basically have one row, which is the equivalent to the parent table, and then in that cell, that would be sort of like the foreign key, reference, right? You can stick an entire equivalent of a tibble or whatever in there with multiple columns, multiple rows.
Yeah.
And so he's sort of saying that if you do it this way, then you can use certain patterns like for loops or per R package to iterate over this, where you say, hey, the columns on the left, I'm going to use as my loop controls. And then I'm going to say for each cell, which is not just a single value, but actually a whole table worth of stuff, go and do whatever the heck you feel like doing.
Yeah.
Build a model, do this.
Exactly. What I said, I jumped ahead. The nested data is exactly that, what you said. Further on, when I started talking about many models, they started in,
So I suspect that he's probably a really strong statistician, but not necessarily a really strong computer scientist. Because I don't know that I would have explained this to a student who has been through a data structures class in, computer science. I think there's a much easier way that you could probably explain this concept.
Yeah. All right. So let's see. So this last part, I was thinking of Margot, because this is kind of what she was doing her PhD on, right? Or her EDD. What was it? What did she have?
She has a DRPH, but yeah, doctoral work on. Yep.
Anyway, but this is similar to the data that Ike's wife had us analyze in our. It was around the HIV and AIDS data from Africa.
Yeah, the government, the military of Togo. And she was looking at behavior and relationship with being either HIV positive or HIV negative, and behavior and the relationship between knowing they're HIV positive and not knowing it, and then behavior and being wrong about your status, meaning some people didn't know they were HIV positive and they were, and some people thought they were HIV positive and they were not. So
a test of significance that you're trying to do there?
Yeah, I think so. Yeah, that's what she was trying to do. Exactly.
What's that?
He was asking if it was a t-test, a test of significance.
Yeah, it was a t-test and a Fisher test and a chi-square test.
I wonder if you played around with this concept of nested data sets like this. That's the proper terminology. I think you would probably find some data sets that would have a different model per category that would fit it better. You know what I'm saying? Like one of the subcategories would be linear and one would be quadratic, and it might stand out that way. I don't know if he talked about that, and I can't remember.
He didn't, I don't think.
Okay.
He did talk about what did he say? He said something about different models for different categories, but I don't remember him saying anything about like different families of models for different categories.
Per category.
Yeah.
Well, I think what he's trying to say is that if you have different patterns on 5 different continents, what you could have done is just built 5 separate data sets, and you could model each one with whatever you want. One of them maybe works great with linear, one of them you need whatever. And you're just sort of repeating your code and repeating your labor 5 times. Or he's saying you could put a data structure around it so that you could iterate over all 5 of them with one set of code. And you're right, you might not choose the same model for each of the
categories,
continents, but at the end of the day, you can still have them sort of organized instead of having just copies of things.
Packaged all together and processed as a whole.
Yeah, so that was nested data sets where you're putting a whole table inside of a cell, and now he's talking about putting a list inside of a cell, right? That's what these list columns are, basically.
It's very much like related tables, as you said.
Yeah, it's pretty much, in my mind, the same concept. It's non-atomic data.
With usual data set, the data frame, you cannot do it. It is a big deal.
So
for R.
Data frame though is like 2-dimensional data list columns, aren't they? Just
in data frame.
It's in a data frame. There is a 1-dimensional list, right?
A data frame is a list with vectors. Each vector should have the same type of data, numerical or text.
But what he's saying is one of the columns of that is itself a list, right?
But it is a table. In data frame, you cannot do this. But in a table, you can.
No,
you can do it in data frame. It's just harder to get it in there.
Yeah, that's what I agree.
Syntax-wise, it's harder to get it in there, but data structure-wise, it allows it.
Yeah, I agree.
No, I tried it. It just forces everything to, usually to character finally.
Yeah, he does say
it changes data type.
It doesn't do it easily, and you have to do some I and other type stuff to get data in and out, but you can do it. It's just Tibble alleviates the problem.
That you change. Okay.
Yeah.
They change the way by which you recall the data.
Yeah. You have to kind of force it in and force it out, whereas
you can present
Tibble and Tribble do it.
You can present everything as a character, and then when you get the data, you need to modify it.
What I didn't like here is that he stopped using the real things that we were familiar with and started using like stupid ranges and stuff. And I was like, give me some real data. I don't know. It felt like too abstract at that point, right? I'm just putting random numbers in here. Look, see, it can be done, right? I don't know. I wish he had stuck with the, here's how I can take the caret data and I could group it by this and put the list of those values inside of this column, and then I could visualize that in some way. It made it more concrete in my mind. Okay, so blah blah blah. Let's see.
I mean, for me, it's sort of like, I guess if you used R for a long time and nobody ever did that, then be like, oh wow, this is like a really neat thing to do. But like, as somebody coming new to R, if you're like, look, I could have a column that has the name of the husband, and I could have a column that has the name of the wife, and this other column, I could have a list of as many kids as they have.
Right.
Like, yes, so what? It's like just not really surprising,
Yeah.
Maybe this was like, nobody ever thought to do that, and this has really saved people tons of lines of code, but it was just really kind of unremarkable. Like, okay.
Yeah, it's a very NoSQL like.
Basically, you're trying to fill in the same cell with the kids' names.
Yeah, because normally in a data frame, you might have like a child 1 column, a child 2 column. You wouldn't ever have.
So yeah, in SQL you can do that actually with stop function. In SQL you can have as many data in one cell with stop function. With XML elements and stuff, you can do that in SQL as well.
Yes, you can do it with certain types of data. Yeah. So XML being one, JSON being another, and depending on the database in question. Yeah, I agree. Yeah, you can. And then at the very end, again, he has this like random little thing. Oh yeah, and there's broom. So again, I don't know, placeholder or something. So it says the broom package gives you 3 general tools for turning models into tidy data frames: glance, tidy, and augment.
And so this is where somebody went and took all of those hidden lists and attributes and said, oh, okay, if you built a model with LM, then I'll use this. If you built a model with GLM, I'll use that. I know random forest model. And so then it's cool because somebody did all the work. So you just use Broom and you say, hey, I want this, whatever, statistic, right?
Yeah.
And it knows where to get it for you without you having to go and look it up.
Yeah, that is cool. So it makes it more of a suite. The libraries are playing nicely together.
Yeah.
I think some of you in here have used Python for doing data science. At least I wonder if they have that same sort of, which you're talking about. They got a standardized structure with all these attributes that are, okay, well now I can write my own package and know that they're not, these names are already existing. But in Python, do they have something like a Tribble? Or,
I mean, if you're dealing with like NumPy, matrices and so forth, then some of the other packages like pandas and stuff can utilize
intermediate results.
Yes, exactly.
It doesn't seem to be quite as standardized.
Yeah.
Maybe because actually there's more people doing stuff, so it's harder to. So maybe a good thing, right? Because there may be more innovation, but
there's a lot of value in learning both of them. I can kind of see it now. Where were talking about before is mathematicians. This was a tool built for mathematicians. And if you've done computer programming and you look at these data structures, it's unremarkable. You're used to it, right?
Mhm.
From a mathematician, they're not really necessarily used to linked lists and whatever all these other things are. And you see it here and you go, yeah. But going from Python, you're coming at it from another angle. It's probably programmers that are wanting to incorporate data science into their knowledge set.
I think we've had this conversation probably every meeting.
Oh, I'm sorry.
No, I'm not. I'm just saying, the differences between R and Python and when you use one versus the other. I think the best conclusion that we came to was that R was the best data exploration and modeling language. Sometimes you have to do things other than data exploration and modeling,
Automated more.
Yeah, exactly. You're automating more of the world than just the world of the data, and then that's where Python can,
Great glue.
be helpful. Yeah, exactly. Kind of glue things together, and also if you're doing it more interactively, like you're building a tool for someone rather than exploring. That was another place that people had said Python might be a better fit than R. But if you are a team of data scientists just exploring data and working with data, then R, because of the fact that everything's global and you don't have to nest, like this package dot this, or, a whole bunch of import, statements or whatever at the top, right? Because they're all global and they're all playing together. Or, like when you import tidyverse, it says, I've just wiped out R's base, stat method or whatever, like I've taken over this thing that is part of the base R package and I've rewritten it for you, right? Because everything's a global, you can do that. Whereas in Python, that stuff is more structured, and you have to put more ceremony if you have two packages that have the same named function or whatever. You have to decide explicitly which one you want to call.
Right.
So yeah, because of the fact that everything's global and playing on top of and with each other, it makes it really nice for data exploration and really difficult if you get more than 10,000 lines of R. It starts like becoming nightmarish because of the global problem.
I see that. Yeah. Thank you.
All right, cool. So I think that was the end of the sort of modeling section, and then we go into this last part here, which is communication, which I thought was pretty fascinating because I didn't know a lot of this stuff going into this chapter, and it's sort of, I had some like random little pockets of knowledge in my head, and this chapter just sort of zipped them all together, which was nice. So the first thing you started talking about was, whoa, what did I just do?
Kept doing that all the time. I was
Markdown.
I think I hit the back arrow a lot.
That's weird. Oh no, it is.
Jumps
Okay.
around.
I see. This loads independently of that. That's the problem. It just jumped because. Yeah, I get it. Anyway, so the first thing he was talking about was when the introduction, it really only mentions R Markdown, but then. But later on, you learn about how notebooks and R Markdown are really the same thing with a slightly different header at the top, right? Which I did not know. I was like, how are they different? Because they're looking very similar. They both have the concept of cells, and then you can run them to produce output. And I was like, God, these things seem like exactly the same thing. Why are there two different ways of doing the same thing?
It's just
and then they are kind of the same thing. They're all based on this R Markdown concept. And then the header at the top basically indicates this is a notebook versus this is a Markdown file that can be, what was that, knitted into a document of your, a report, a printable report,
Yeah, it does PDF, HTML file, and it does presentations, slides.
Yeah, exactly. A report, be it document or interactive. That's what I should have said.
Well, thanks for that recap, because you're right. They weren't really explicit about,
Yeah, and we had discussions in the very first meeting, like where people were bringing up this thing, these things like, oh, you're using Jupyter. What's the difference between that and R Markdown? And I was like, I don't know. They seem very similar, I think was my actual answer at that time, but I didn't know the difference. And I think at one point during the exercises, he says, create one of these, the notebooks, and then create one of these R Markdown files, and then actually look at the differences. And I think I did that. Yeah. So here was a notebook. Let me zoom the heck in. Tell you what, let me open it up in Notepad. Let's try that. That has a better font for presentation. Hopefully that didn't do anything bad to the screen there. RMD, yeah. It doesn't do that, does it? All right, fine. One at a time then.
That's much better.
Yeah. R Markdown. Okay. So if I doc. Right. So that is ultimately the difference.
Wow.
It's very subtle.
No, not really. They can both have Markdown in them. You can both have, look, they both put the triple tick for executable code. They're like exactly the same, except for that.
Huh.
And then in RStudio, he says later on that when you save the notebook, it saves the HTML and the markdown file.
Yeah.
But also that the standalone HTML has hidden in it the entire R Markdown file.
What do you mean
So-
in it? It is separate. You can find it in the same directory.
I don't know how, but somehow in comments or whatever, it embeds the actual RMD into the HTML, because he said if you email the HTML to somebody, they can actually say, I want to edit the R Markdown, and it'll just open the R Markdown file for them. Yes.
I guess you could use.
I was curious because I haven't used Jupyter much as to how its handling of R Markdown differs from Jupyter, because there's a R kernel for Jupyter.
Yeah.
Use Chrome tools and go inspect it. So you think it's actually embedded in there and just.
Well, that's what he says. I didn't actually test it
You
out.
can recover it. That's true.
So it must somehow be.
You can.
This
Can
is
be put in there as a comment.
Okay, but
Yes.
I mean, I can look at the HTML file, and sometimes when I need to change some very small in my post, and I don't want to go through the RStudio and need it again, I can open a HTML file and, for example, fix a spelling mistakes. This I know I can do.
No, but what
Is it
what
he
Ted's
means
saying is
by-
that, so it's this. Hold on, window, initialize, source, embed, notebook.rmd. Hold on 1 second. Never do a demo on the fly. That's it. Okay. So I don't know where.
All
You
text
send
is
the
here. All my
HTML.
commands is here. And
Yeah, I mean, he says if you open the notebook HTML file,
Which I'm
RStudio
looking
will
at.
automatically recreate the .rmd file that generated that HTML file.
Interesting. Interesting. Yeah.
So again, I don't really know how. I'm just reading what he said. So
Interesting. Interesting.
So basically, he's saying you can't
Let's try this.
accidentally create the HTML with one version of your notebook and then forget that it's not the latest and whatever, that anybody who you share it with will automatically have the source notebook,
Which is convenient. I mean, if
Yeah.
you're sharing work.
So it's not secure if you're trying to keep your work proprietary, but if you're collaborating, then it's fail-safe.
I try to open it and I just use HTML file. I just see it again.
Yep. It's so true.
In
I have no idea how it did that, but it did that.
It did? You
Yeah.
got it?
You deleted the RMD? Or?
I moved the HTML into a separate directory. I opened the HTML file from that directory. I'm now looking at notebook.rmd, which is not the file that I opened. I opened the HTML file in our studio. And now I'm looking at the notebook.rmd. So clearly it's in one of these gigantic strings that it has here.
Yeah, I mean, it could be like Microsoft where it's hashed.
Base 64 encoded, rendition of the thing or something. But
if you turn on word wrap, you could see which ones are really big and which ones are. But it still won't help you read it. It'll still just be gobbledygook.
Yeah.
Up above there's a hide code. Did you notice that? That file you had open, that HTML you were showing?
I think that might actually be a function, though. It might actually be a hide code.
The notebook
it's like a JavaScript.
Oh, no,
no, like
the
the user who's looking at the web page.
Right.
They can say, "Oh, I don't want to read all your yucky code. Just hide all those spans and just show me the outputs."
If that gets loud, we can shut that door. So
Okay.
they come through at night and do their thing. Anyway, so let's see.
It's pretty clever.
Yeah, that was. I don't think I put that together from the reading. That it's somehow embedded inside of that.
Yes. So clearly, like if I'm sharing it with a non-technical person, a manager or whatever, then if I just knit a regular R Markdown to HTML, I can send it to them, and then whatever. But again, that's where, in theory, if I have work that I keep tweaking and tweaking and tweaking, I could have multiple versions of that HTML. I could accidentally lose track of version control or whatever.
Yeah.
Okay,
But with the notebook, you don't ever have to worry about that because
this is good to know.
they just and they have Now they may say, "Hey, wait a second, this is not your latest, notebook."
Yeah.
And then you're like, "Oh, sorry, I sent you an older one." But
But
they would never have that mismatch where the HTML doesn't match the R code that they're looking at.
Yeah, that's pretty cool. Alrighty. Let's see. And then, so that, he didn't go into a ton of additional information. So he mentioned the caching. He mentioned you can tweak the YAML headers to embed metadata about the document itself. And especially he mentioned like the setup section that you can specify which libraries and stuff that you need. And then he also talked about bibliographies and citations. That's also metadata as part of the document that you may not want to be upfront and visible while you're looking at it, but you may need someone to have access to the data so you're not accused of plagiarism. So that was a good place for putting that. Okay.
There's some place in there they were mentioning all the options for those header values. It seemed like there was an awful lot of them. I didn't go look at how many there were, but did you see that?
Yeah.
Didn't even understand some of them, but there was a lot. I guess that was for creating the different document types, you had a lot of power to, tweak how those different document types were formatted and so on.
Yeah.
You can use LaTeX in Markdown. Anybody's interested in how to write formulas? math formulas. Oh, okay.
Well, I think.
You know what I thought was cool? I'm sorry.
Can I show one?
When they showed the axis, when they actually printed it out in math symbols,
Yeah.
I thought that was pretty neat. I don't know what fonts they were using. You remember that part in there?
Yeah, I
We're
do.
showing
Let me see if I can
stigmas
find
and,
it.
and yeah.
I had to do that because I had a chart where I had like Muse,
Uh-huh.
and I was like, so I just did the little math thing and
You don't
Wait,
even
was
have to
that-
think about it.
say MU, and it just draws a little Greek character.
Hold on.
This
That
one
may have
here.
been actually in the next chapter, right?
Yeah,
Yeah,
that
it's a
one.
nice
I
chapter.
just went, wow, that's not this. They make it
Yeah,
look
I've never seen
trivial,
that
but
before.
it's not that trivial
Yeah.
under the covers. I don't think at all.
Which part was that in? I'm sorry, I couldn't.
It's the second chapter, right?
22, graphics for communication with ggplot2.
Okay, so labels, annotations, scales.
Or was it the end of the chapter?
Yeah.
My chapter numbers might be different. Here's showing.
Sometimes they were off by one.
But it was the
Two
GG
different
plot
versions.
chapter, right?
Yeah, ggplot chapter, exactly.
I remember seeing it. I don't know where it is.
I don't remember. I remember seeing it.
Oh,
there
no,
it
it's
is
the
right there.
beginning. The beginning.
So
Yeah,
The GG
it's-
plot chapter. It's like the third
yeah.
page.
Quote. That was what it was, right?
Yep.
Just switch out for quote and read all about the available options in plot math. Yeah.
It is
Plot
not
math.
necessarily for plot. You can use. You can put in any Greek letter if you use.
Yeah. That's what
in
he
the
has.
text.
That's what he has.
In the
is
text.
Yeah.
No, just in the text. You can do it in the text. If you
He has that.
use dollar signs.
Right here, I think, but it's not yet loaded. There we go.
There it is.
There.
And he's like,
Yeah.
oh, there you go. And I went, wow, that's actually pretty cool.
Yeah. Alpha plus beta plus fraction of delta over theta. Yeah. And then the
I
sum.
guess sum gets you a big sigma.
Yeah. Sigma. Yeah.
Well, you can do it in the text too, but in the text you don't use quote function. You use dollar signs.
Yeah,
And
so if
you
you're
use
doing GG
backslashes.
plot, you use quote. If you're
Yes.
using markdown, then you just use the dollar signs, and you can use all that same syntax.
And
So
you
if-
need to
if-
use
yeah.
backslashes.
If,
That
if in your prose in your
Okay.
notebook you want to talk about
Yeah,
a
that is
mathematical
a
thing, you can drop the same functions.
yeah, that is a R Markdown extension, which is a standard Markdown library that you can incorporate in other Markdown tools. Yeah, I've used it before, but it's been so long I'm not remembering when or why or where. But yeah, that is a standard Markdown library that you can use,
That's cool.
even if you're not in R. Because I know I wasn't in R at the time. I don't even know that I knew that R existed at the time. Okay, so yeah, I mean this chapter, I don't know, it felt a little bit weird in that he's just talking about all of the different things. This is like reference material, like all of the different ways that you can customize the plots.
Mhm.
And it's also weird that it happened at the end. I guess he's following the workflow, right? You've got the model. Now you want to impress somebody with it.
Right. If you're just visualizing it for yourself, you don't need a title.
Yeah, exactly.
Eventually you will.
Yeah, and then we have those. This is the chapter actually after that, after the ggplot chapter, we have the markdown formats, and that's where he was talking about the YAML headers and what they actually the difference between the two options. And then he mentions Shiny, which I know we had some questions about early on. And it seemed like HTML widgets was the client side way, and Shiny was the server way. So if you have, locked down browsers or something like that, you would prefer Shiny over.
No, then you would
HTML
want
widgets.
client side. It's locked down.
Well, no, if it's locked down, my point is.
Oh, like it won't run all the JavaScript stuff.
Yeah.
Sorry.
Yeah, if you have a locked down
then you
browser,
want server side.
right? Then you'd have to go server side, but otherwise.
But if you're offline, then you'd want client side.
Yeah, client side, I guess. Yeah. So it seemed to me that the way the world is going, wouldn't you prefer HTML widgets?
Yes, I really think Shine. I'm speaking for myself. I think Shiny was something that was done for our people, and it's kind of like, do you really want to run a separate Shiny server on along with your web servers just to support that? I don't know.
Yeah. I see.
But if you
don't
had
have
like
any servers for yourself, you can rent.
For yourself, yeah.
Yes.
Yeah. Then you don't need to run a Shiny server for yourself, right?
But imagine you had a ginormous data set, but you were just showing a small little chart. Well, then doing it server side is feasible, as opposed to having to glom that whole data set onto the client side so that they can then run. And they have to have R, not just browser, but they have to have R, don't they? Or is it just in JavaScript?
To do Shiny on the server side, you have to have a special Shiny server-side server.
You have to have
Can you guys hear me?
Yes.
I know that Shiny is part of it used to be called Microsoft R Server, but now it's called Microsoft ML Server. Yeah. And they have the Shiny package deployed on that server so that you can run Shiny code.
Oh, so it's not.
Oh, so if you're in Azure, you can.
Is you put it, the web page, and anybody who comes to this web page can play with it.
Yeah, but the same thing can be done in HTML widgets, and that's what I was asking.
Okay.
Like, that's what I was asking, why you would use one versus the other. And it seems to me like I would always prefer HTML widgets because it's always client side. But you're right, if the data set is so large and you're only visualizing a small portion of it, then you might want to do it server side, not client side. Yeah. So I guess.
Well, I also think that there's technical expertise that's required for HTML wizards that isn't particularly required for Shiny. So it might be just that data scientists prefer Shiny because it's easier to implement for them. But I might be wrong, but that was my take, is that maybe the people that are using Shiny are not developers.
I don't know. He said that if you're just playing around, it'll fire up a Shiny on your PC, and I didn't get around to, but I wanted to actually try testing that out and just see if I wrote that in RStudio and it just fired up the web page.
I'm not understanding what you're saying, Ike. So it's just
Shiny
libraries like DY graphs and 3GS and whatever. So what are you saying? Like,
I'm saying that implementing HTML widgets, I didn't actually do it, so maybe it's easier than I think it is. But doesn't that imply?
So it'd just be like, import this package, now use that function to do some cool interactive thing.
But isn't it interactive in the browser? Isn't it interactive in Chrome?
Yeah, in all the browsers, yeah.
And it doesn't require knowing any JavaScript or any HTML?
Correct.
Yeah,
okay.
I think it just knits to an HTML with embedded JavaScript that creates the interactivity.
Exactly. Yeah.
You don't
okay.
Yeah. So it's in both, you're doing R, but it looks like why would I want to do server? That's my original question.
Right.
Why would I want to use server side when I can do client side? It would seem to me, but I get what you're saying about the huge data set. That would be one case where the transferring of the data all the way down would cause the latency issue before the HTML widget appeared, versus you already have the data loaded on the server side. You can render something which is transferred down, which is much smaller. So that makes sense. You want to plug in over here?
Yes. Shiny could be done in RStudio.
So could HTML widgets, but you just...
Yeah.
Yeah.
Thank you very much.
Yeah. So, yeah.
I think the one thing he mentioned, though, if you wanted to publish it out in a public website, that in order for anybody else to be able to look at your published HTML pages, you would have to have the support of a Shiny server out on that public website in order to use the Shiny features. I have to go rewrite it, but I remember believe he said that was a disadvantage.
But Ike was saying that in Azure now, if you're using that, Microsoft has a Shiny server as one of their.
Oh.
And so then if you're doing R on Azure, then you can just use their built-in Shiny.
Yeah. Actually, Azure ML server is an on-premise product that you can install.
But you can also access it on Azure.
Oh, yeah.
Yeah.
Oh, well, then it's...
But it's also on-premise. It's not
also on-premise, yeah.
Limited to Azure, yeah.
Let's see. And so the last thing in that chapter is he talks about book down, which happens to be how he wrote this book.
Yeah.
Which I thought was pretty cool. So that's an amazing example of and I think a lot of technical books these days are being written in some sort of markdown flavor, because it makes it easier to source control, right? To go back and revise and that sort of thing.
I have an O'Reilly, a Safari book subscription, and I think you were right about that.
Yeah.
Because the format on there it's a little bit different because you try to cut and paste stuff. Just to give you an example, it's not if you cut like some code, like 5 lines of code, it runs them all together as a string in your text editor, right? So it's doing something special, like there's some sort of markdown.
That's what I'm reading on too.
On that, yeah. That's kind of frustrating. And what I did was I found out there's a free copy of the book, and you can just
PDF of it? Or?
Yeah, no, this is an HTML copy of it.
Cut and paste out of there a lot easier.
Yeah, that's what I've been showing you here.
Yeah, it was frustrating.
Yeah.
Trying to copy and paste those examples.
Yeah. Yeah, that's what, in the beginning, I was doing that too. I was just typing out everything. And then it's just too much, right? Like
after a while, yeah.
Anyway. Let's see. And then the articles is the only other one they mentioned. So book down, pretty doc, and articles are 3 other formats that are useful for creating hard copy stuff. And then he has like a little tiny page about the R Markdown workflow. And I think that wraps up nicely with what we were talking about, what Ike and I were talking about several times during the book is I really like the notebook format for data exploration and documenting what I did, and the fact that I can send it to someone and say, this is what I did, and they can go and they can edit it and say, what if you had done this instead? And it's like living, documentation that's always runnable and changeable. And it's, I think it's like a huge advance in, scientific notebooks and in the way you do science. I think it's a really positive benefit on the community as a whole, even outside of R.
Yeah, that's cool.
This is all open source. That's pretty amazing, isn't it?
Yeah.
That's a lot of generous people put some
Exactly. Exactly.
Wow.
And it's not you copying your code and pasting the results,
Right.
Over and over and over
Yeah,
again. It's
yeah,
just nice UI.
Yeah, all of it. I mean, like R itself and
All
many
the
other
packages.
packages, and Jupyter is all open source, and Ike mentioned last time that Margot's stuff, his wife's stuff was in SAS, and she was having all kinds of problems, getting it to run or whatever, and then we just got everything out and into R, and bam,
Wow,
just
that's
so
amazing.
much easier.
SAS is not cheap. I know it's not.
Exactly.
Yeah.
Exactly. Okay, and
I know you were talking about the community, but as far as like getting help too online, like every single time Margot and I got stuck, it was really easy to find where people were helping each other out. Except for Google, you have to Google R-Lang. But
yeah,
the only problem with R is the name of it. It's such a stupid name.
Yeah, no, I agree. I agree.
So how do you avoid the fact that the letter R is just too big?
R-Lang.
R-Lang.
L-A-N-G.
Like 5 letters, R-L-A-N-G?
Yeah.
You can
As in language, I guess.
you can use R code because this is what they use in Stack Overflow.
R-C-O-D-E?
R.
Yeah,
space,
R code. Yeah.
C-O-D-E.
Oh,
Space. But the space doesn't mess it up so that it's just finding
Somehow
R's
it
all over the
doesn't.
place.
Yeah, I think Google will just the way it works, right? Links. You're basically saying, I want R as a single letter, and then the other terms that you're using would tend to focus you on when it's R as a single letter. It would be the language R.
you're absolutely
Anyway.
right.
Yeah, but if you do use something like R-Lang or in Stack Overflow, the tag R code, then you're guaranteed to filter out those other results.
I first tried R out several years ago, and I would type R this or that, and put it up. I would never get it. Google's gotten a lot smarter. You can just say R and then something related to coding. Yeah.
I was like, I need a running total in R.
Yeah.
Right.
So we have fans. You guys are obviously working in data and data science and statistics and or a related visualization field. What do you guys want to stay in that area? Like, what would you come back to do more TIG? When we talk about the topics earlier, we said Docker and Kubernetes, Spark and Databricks, Python for data analytics, or generically Linux. What would you guys want for the next session?
The first two, because I know Python for data analytics.
Wait, she's. I'm sorry. What was your name again? I can't remember.
My name is Maya. But we
Maya,
can,
yeah. Maya.
decide this democratically by vote.
Yeah, I mean, in the past, we've done a voting sort of thing. So whoever attended the last one of the previous session basically got heavy influence into the next session. This topic was actually just chosen by Ike because we had moved. We used to be in Carlsbad. We moved locations, and we had taken a 3-month hiatus, and Ike just wanted to learn R.
And I have learned a lot.
Yeah, me too.
I'm not super good at it, but I've learned a lot.
Yeah, me too, definitely. I feel like I could, with some data, and I know I want to visualize it or maybe form a model out of it or whatever, I could get started and I know where to go for help. That's about, all you can ask really, because Unless you're playing in it every day, you know,
If you're interested exactly in our package, you can use cran. Cran is the name of the package.
But we don't have to vote where we raise our hands because there's only 5 of us. So, like, if you had to choose between those 4 topics, what would you choose?
I only see 3.
It's Docker and Kubernetes, Spark and Databricks, Python for data analytics, and Linux. It's 4.
No. Well, the Linux thing, I think we'll cover it in Docker.
I think we got to. I think it's gonna be kind of mixed because I know Docker fairly well and Kubernetes. If you know Python, you're just saying you know Python.
Yeah.
All right, so let's just do, since we only have 3 topics, let's just do single vote, right? Okay, so single vote for Docker Kubernetes. Like, you picked your one that you want. Yeah, I would vote for that one actually. 1, 2.
Okay.
All right. So
Everybody else
then we got 2. Apache Spark and Databricks.
I would vote for that.
Wait. Single vote.
Okay, am I the only vote for that?
Please.
Okay,
Hold on. No, Ike, you're voting for that one? Nope, that's
Yeah.
also 2.
Now,
And
can
Python-
I sell that one for just a second? Can I sell that?
Sure.
How
Well,
many?
then can I sell Docker?
Yeah, but let me just talk about it in case you don't, because everyone knows what Docker is, but you might not know what Databricks is. So Databricks is the company that the guys who wrote Spark started when they spun off and created their own company. And it's what we've been talking about in this class, where we've said, oh, you're in Jupyter Notebooks and you write in R, and then you hand it over to a data engineer and they productize it. The idea behind Spark and Databricks is twofold. One, that the notebooks are productized almost immediately, that you can productionize the notebooks without a lot of extra work. And so it's a way for data engineers and data scientists to work in the same IDE when they are getting their work done. And the second thing is it's a really easy way to do interactive and batch querying independent of the data source, whether the data source is HDFS or it's HBase or it's, you know, anything sitting on S3 or anything really, even like MongoDB. The query language that you use to interact with the data source really stays the same. So, but that's okay. I could be the only one interested in it. I just,
well, so far we have 2 and 2, and we haven't voted for Python for data analytics yet. So
okay, all right.
Anybody interested in that? That would be
I would vote
1,
for
2.
that.
Well, there you go.
So,
if
I could
how's
just
that?
I'm kind
comment.
of abstained because I like Apache Spark and Python. How's that? So
Yeah.
you
So
want
half
me a
of each,
tiebreaker?
yeah.
Scott, if I could just comment. You remember there was that one month
I would do
where
a tiebreaker. I
we
guess.
unfortunately canceled the meeting, like the schedules and whatever.
Yeah,
just didn't work, right?
I had the last thing, and I
Yeah.
had the last minute thing. Yeah.
And it seems like that was the month that we lost the most people.
Yeah.
Right. And so I don't know if there are other people who maybe would want to come, and I don't know how to figure out what they would want. What would get them to re-engage, right?
Yeah.
But ideally, you would want for session 1 where you
put it up for
40
a
more
public
people
vote, is what you're
here.
saying. Yeah, put it up for a public.
Well, I'm less interested in quantity, honestly. Like, I was thinking that when we met with Ted and it was just the 3 of us and how interesting the conversations were. Like, I like this meeting today. Like, the people in the room, I would much rather make sure you guys all come back and we stay small than appeal to the masses and who knows who we get.
Okay. I presumed
That's
wrong
true.
that you would actually want quantity.
No.
The thing is that people can vote and they won't come.
Well, yeah, right.
Yeah,
Yes.
One thing about Apache Spark, and maybe you already know this, is functional. It's based on a functional language column.
Yes.
I like functional languages, so
Me
that's
too.
why I was having a hard time deciding myself.
Yeah.
So I could easily go with Apache Spark.
You know, functional languages, I mean, they weren't on here last time we voted, but it has definitely come up many times in the past. And if you look back, I mean, this is just my OneNote notebook, but if you look back, like our previous topics, I don't think all of them are up here, but a lot of them are, right? So you have R, and then there was UI, user experience, design, Linux, DevOps, Python, Angular, HTML, CSS, JavaScript. That was that SQL Pass book readers. We did a little Hadoop thing that was sort of side from TIG.
Okay.
But anyway, mobile, Entity Framework, T-SQL. Oh, sorry, ignore those two. And I think the very first ones were like, I think the very first one was C#. So that's not all of them.
Can I ask another question of the group here?
Yeah.
Is there any topic that anybody here would not come back for? They wouldn't be interested in coming back for? Because for me, I would come back. I like all three of these topics. I think they're all great, but
I'd be okay with all three, but didn't we already do Python? That
Yeah,
was when
yeah,
I
yeah.
started with you guys.
Yeah. We've done it, but so hold up. We did do JavaScript twice.
You sort of did a functional language.
Yeah,
Semi.
Not really though. Yeah. So we did JavaScript, HTML, CSS. I think we did JavaScript again, and then we did Angular.
okay, Scott.
Yeah.
I think you should just be the tiebreaker and pick it then. If it's 2-2-2 and nobody has a strong opinion about not doing it, then you should just pick it right now.
Yeah, you're the one who definitely
You're the
will
one
be.
that has to do it, so
Yeah.
you should hit that.
And no, I didn't hear anybody answer no. I think everybody agreed we're fine with any one of the three.
Yeah.
Really, I would come back.
I would definitely come to session 1 for any of those three. I don't know if they all have the same stamina for
Yeah,
me, but
yeah.
I would at least start out.
So that's interesting about the functional language because I would really love to do one of the, I would love to do Scala, actually. That would be a great one to do. But I think that would alienate. I think, not many people would be interested in that.
I would be interested in it.
If you want to stretch your
I
mind
am
a little bit
interested
and you
in
haven't
Scala
done
and
functional
in Apache Spark.
programming, it's
If I can change my vote, I
kind
would
of
go
fun.
to Apache Spark.
Yeah. So, but if we did that, right? If we did just a little bit on Scala, then Apache Spark, and then Databricks, that would be a super long track.
I don't
Which
know
is-
that you can do Spark without Scala.
Did
Oh, you can.
discuss
No.
immutability?
There's
Yeah, you can do it with
PySpark and there's-
Python.
Oh,
Yeah, you can do it with Python and R. Yeah.
Yeah.
I'm sorry.
Go
Did
ahead,
you
Mike.
discuss immutability when you did Java? Because it is, some kind of strange topic for me. Immutability?
Yeah, immutability would be definitely something that would come up if you're doing a functional language.
Yes.
When we were doing JavaScript, I don't think it came up. It came up in C#.
Okay.
On the topic of strings and some of the other things, but I don't think it came up in JavaScript. But so we could do a quick, I'm just worried that, because the last time we had a super long talk was Python. We had 2 months on the language, 2 months on web, 2 months on machine. I think it may have even been 3 months on the web and 3 months in machine learning. And it was 8 months total. And by the third meeting of machine language, I think it was this size again. And that was, we started with probably 50 people. And by the time we got through the 8 months, it was down to 5 or 6 people. So those super long tracks, people feel like if they miss one, it's oh, I'm so far behind. I don't know. I won't know what they're talking about. And then it's sort of, there's a natural atrophy, through the lifetime of the talk. And so anytime we start doing a big one, it really affects attendance.
Big. Scala has a learning curve, especially if you're.
I don't know
not into
Spark.
functional.
Is there a way to sort of say we'll do Scala and then now we're doing Spark and give people a jumping in point?
Yeah. Yeah.
Can't
there
you
is.
use Python for Spark?
Yes. And R.
Yeah, no, I didn't realize that. You don't have to use Scala.
Yeah.
Something else.
Yeah. All right. So, but I would totally be interested in doing that one as a separate topic. But
What's Databricks? Did you say, is Databricks rely on a particular language, or is it a library in itself?
It's basically platform as a service, Apache Spark.
Okay.
And that actually, as I think about it, now that you say that, that might be a killer, because how can we afford Databricks? Like, it might be a killer just because we might not have access to it. Like with R, it's really easy because everything's free, right?
Yeah.
Docker and Kubernetes, everything's easy because everything's free.
Right.
But Databricks,
Apache Spark, you can run in a Docker container. You can run Apache Spark locally.
Okay.
Actually, no, even in Windows.
That's what I'm saying, on a Windows.
Yeah, on a Windows or Linux. Yep. Actually, using Kubernetes, you could orchestrate a whole Apache Spark cluster.
Yes.
Right.
Well, there's your answer. We learned Docker Kubernetes, and then we use it to do the other stuff.
So I do think that's a good point you bring up, Ike. Like, practically speaking, if we do Spark and Databricks, right? Like, how are we actually gonna do it?
Yeah.
Right?
If you
and also we'll need to like find a book, right?
Yeah.
So I
for
assume that
any of these
books are
we'll have to-
available for everything.
Yeah.
So
For any
not
of
too
these
worried,
books would be
but,
available. Yeah. We'll just have to pick the right one.
But yeah, like R, it's just like, okay, just go download it.
Yeah.
It looks like they have a community edition.
Spark?
Databricks.
Or
Yeah.
what? Databricks?
Yeah.
Okay.
Limited to 6 gigs.
Okay, so you can play around.
It might not be. Is it trial based? Is it have a time frame?
No, there's also a trial that's the full version, but that's only 14 days. But the community edition is just
6
for
gigs. You
students
can
and
use it forever.
educational.
Okay. Did you hear that, Ike?
What?
There's a community edition of Databricks, freely available.
Well, okay. We still haven't picked a topic though.
Yeah, that's true. Well, I mean, if we want, so we did say after the Linux track that Docker wasn't not Docker, sorry, Docker on Windows, because we had a lot of Windows users, wasn't quite prime time at that point. And that was
so, and never will be.
No, it was. No, it is. It totally is now. No,
It's
at
not-
the time, Docker for Windows, it was out, but it was like revising every day. The Linux subsystem was interfering with it. Nested virtualization wasn't really a thing. I mean, this is a year ago.
You know what I did? And I have a Mac, but you just spin up a virtual machine.
Yeah, but you don't
That's
even
the
have to
best
do
way
that
to do it.
anymore. I mean, it's
I know. It's
yeah.
integrated in there, but
Yeah, it's nice. It's much nicer now
Yeah.
than it was. And I've done both the Docker for Windows and the Docker for Linux on Windows.
You can do it both ways.
And both of those have worked for me. Whereas a year ago, the Docker for Windows on Windows was
shaky.
Super shaky.
Same with the Mac; it wasn't robust.
Yeah, exactly. So in the year since we did that TIG Linux track, year and a half or something like that ago, here, I can find out exactly, can't I?
I gotta go to bed. I'm sorry, guys. I got a class early in the morning, so I'll let you guys decide this, and I gotta run.
Like 2 years ago, basically, is when we started that track, or not quite. I guess a year and a half ago. Anyway, so I think we could let's try and do a quick Docker Kubernetes track.
Okay.
Like 3 meetings, something like that, where we maybe, the Docker basics, and then we talk about some, like the Docker networking type stuff, and then we talk about Kubernetes for orchestrating, a set of Docker containers. right? Just 3 separate meetings. We'll try and come up with some material there, and then we'll move on, and maybe that'll help us in Spark, or at that time, maybe we'll be excited about something else. Who knows? But we did actually say after the Linux track, now that I'm thinking about it, that we did want to come back and do Docker. So if we do a quick Docker track, then we'll do Apache Spark after that. All right, so what we normally do is halfway between this meeting and the first Docker meeting, we'll put out a little intro video where we talk about the book. Or sometimes it's not a book. Sometimes it's just various blog articles that we put together or whatever. Sometimes it's like web-based. So be looking for that. We'll try and post an announcement on the meetup. And try and keep it short so we can get to other stuff that we want to learn about.
Okay. Docker short. Kubernetes is a little more challenging.
Yeah, no, that's true. Yeah, it is. But I think we can talk about, you know, some of the basics and some of the small little programs that you use within the Kubernetes ecosystem, and you know.
And actually, if it's decided to use Docker for doing something else, you don't really need the Kubernetes part. It's
Not necessarily. Yeah, that's
stuff,
true.
right?
Yeah.
Unless you want to scale out.
Yeah, exactly. Okay, cool. So we'll try and do that. Three. We'll try and keep this one short. All right. Well, thanks everyone for coming. I'm going to go ahead and shut off the meeting.
You this can be discussed about supply functions and map
Map function.